All right, so this is where we're at with this one. X is approaching positive infinity, so we're going to use that definition for the absolute value of x cubed, which is the square root of x to the sixth. So then that just means, since x is approaching positive infinity, on the top, we just need to divide through by a positive x cubed. So just rewrite what we have. And honestly, not all of these steps are necessary. Just kind of utilizing this to show you what's happening. So I'll put this over here again as a reminder. The square root of x to the sixth equals x cubed, since x is approaching infinity. That is, x is larger than 0, x is positive.
So we don't have to put the absolute values in every single one of them.
Right, so you don't have to put the absolute value here, because just by the definition of where this limit is, it's already telling us which piece of the absolute value we're using. We're using the positive piece because we're going towards positive infinity. So the previous page was a more algebraic argument. With that in mind, when we compute these limits, we can sort of just default to one or the other depending on where that limit is at. Okay, so our simplification then, we've got the limit as x goes to infinity. First term simplifies to 10. This is minus 3 over x plus 8 over x cubed. And then we have the square root of all of this stuff on the bottom. That simplifies to 25. This is 1 over x squared. And the last term is 2 over x to the sixth. And then we just compute the limit as x goes to infinity. 10 stays 10. What does 3 over x approach? 0. Plus 8 over x cubed approaches what? 0. Over the square root of 25 stays 25. 1 over x squared approaches 0. 2 over x to the sixth approaches 0. So what do we get for that limit? 2. 10 over root 25, which is 2. 10 over 5 is 2.
If you get that plus 6.
Do what?
That's plus 6.
Oh, plus 6, yeah, well, I don't know what that is. 0. Thank you. Is that all right? Does that make sense? A little bit more analysis is involved, but so how do you think the -2 emerges as another horizontal asymptote? Just by seeing this one worked out.
As x approaches negative infinity.
Yeah, as x approaches negative infinity is how we get the -2. Was x approaching negative infinity, what changes in all of this stuff that we've just computed?
Minus x cubed.
Yeah, as x approaches negative infinity, for all negative numbers, we have to not divide by x cubed, but we have to divide by a negative x cubed. So that's what's going to change in the next computation. But this result that we've computed here, as x approaches positive infinity, y approaches 2, that gives us this right here. As x approaches infinity, y approaches 2. So that gives us that horizontal asymptote on the positive end. Now we need to look at that function, what's happening on the negative end. So the other end is limit as x approaches negative infinity. On the same function, so well, I didn't quite get it all, but save a little bit of writing anyways. So it's the same procedure, divide by the highest power of x in the denominator, it's x to the 6th, but here we're going to divide through by negative x cubed. And remind ourselves that the square root of x to the 6th equals negative x cubed, since x approaches negative infinity. In other words, that is, x is negative. Outside of that, all of the limits are still exactly the same except for this one up top, right? This is now negative 10. Are there any questions on that? Same procedure. So this is now not 10, but this turns into negative 10. This is still, was that plus or minus? That was minus. And honestly, the lesser terms aren't going to matter because we saw they all went to 0, but we'll go ahead and write this out. This is now positive 3 over x. This is minus 8 over x cubed. This is still 25 plus 1 over x squared plus 2 over x to the 6th. So that limit gives us negative 10 over root 25, which is negative 2. Yeah.
Would we be able to just compare what's it called, when you just divide it by the highest term instead of doing all the other work?
Yeah, we'll look at that in just a second. Yeah. Yeah, so this is the long way.
And is there a situation where the other numbers would not equal 0? The preceding numbers after the terms?
As long as the function's arranged in descending order of powers of x, those lesser terms would go to 0. Yeah.
So how do we know that it's the square root of 25 would be 5 rather than minus 5?
Because we know that this is going to be 5, not minus 5, because there's not a minus out in front of that root like that. Any other questions? Okay. So that gives us the other horizontal asymptote out here as we approach negative infinity. Y approaches negative 2. Out here at negative infinity. So that was the long way. The short way was more or less where we said, well, just look at the leading term or the highest power on top and the highest power on bottom. All of those lesser terms, as we see, they don't matter. They're inconsequential. So I guess we could call this the easier way, but you still have to remember the positive negative stuff. There's really no way around that. I don't know, easy, I guess again, a relative term. It's based on the easier way we looked at when we computed limits on rational, limits at infinity on rational functions. So if we're asked, what's the limit as x approaches infinity on a function? We can still look at kind of leading term, if you will, divided by leading term. That's a minus. I messed up and didn't want to erase. Okay. So as long as we're discussing limits at infinity, then we can say that this limit is approximately or pretty much the same, identical to this limit. Right, all of those lesser terms are insignificant as x approaches infinity. But then you still have to simplify this algebraically. So what we end up with here, well, I'll take it down here. Jeez, what is wrong with this? There, I think that's good. So it's 10x cubed over the square root of 25x to the 6th is 10x cubed over 5 is the square root of x to the 6th. So we can simplify that from here. 10 over 5, that's 2. So we've got 2x cubed. And we know what the square root of x to the 6th is. It's the absolute value of x cubed. And so this is 1. This is 2x cubed over x cubed if x is positive, right? But it's 2x cubed over negative x cubed if x is negative. So then that way we've got both a positive 2 coming out of this limit at infinity and a negative 2 out of this. So let me scoot that up. I'm kind of scared to do that. Fail. There, oh. Okay. Okay, maybe not get that. I don't know why it's doing that. So this one's for our limit as x approaches infinity, and this one's for our limit as x approaches negative infinity. So I think once we've seen the algebraic simplification of square root of things to powers like that, it's probably a little easier to take this approach, but it's relative. Whatever works for you, whatever makes sense to you, use that. Are there any questions on that? So there are a few similar to this in your homework. If you have any issues, if you've seen it.
Just one.
Just one? Okay, there's one. If you have any issues with it, feel free to ask in class. We can go over it. Any questions at this point? No? Okay, moving on. So what's the end behavior of e to the x? I mean, the easiest way to know what it is to remember what the graph looks like, right? But if we forgot, end behavior again asks us to compute the limit at infinity or negative infinity. Now, we've kind of been using that end behavior meaning limit at infinity, negative infinity sort of loosely. It really does depend on the domain of the function. So we'll see kind of a modification sort of in the next example. But end behavior just means a limit on this function's end over here and the function's end over here. Not all functions begin and end at infinity. So what's the limit as x approaches infinity of e to the x? So think about it this way. What's e, which is 2.71828? What's that number raised to a larger and larger power? Is what? Infinity, yeah.
What does the graph look like again?
We'll be able to tell in a minute. We've got one end.
Let's just care about it.
The other end is as x approaches negative infinity on the function e to the x. So what would that be?
Zero.
0. It's 0. Because we have a number, think of it this way. This is e to the negative infinity. How do we handle negative exponents? To make them positive, you do what?
Put it on the bottom.
Yeah, put it on the bottom. So it's really 1 over e to the positive infinity. And we know that e to the positive infinity is growing larger and larger and larger. So we've got a numerator fixed at 1, denominator getting larger and larger and larger. So the quotient gets smaller and smaller and smaller. So this is kind of like saying it's 1 over something that approaches 0. 1 over something that approaches infinity, which is 0 with respect to the quotient. So positive end, there is an asymptote, a horizontal asymptote, but on the negative end of this graph, there is an asymptote at y equals to 0. So does anybody remember what the graph of e to the x looks like? Let me do this up here. We drew it out a while ago, but here's e to the x. Towards negative infinity, the function's flat at y equals to 0. Remember, that's the point 1, 0, 1. All right, so for example, having e to the x, knowing its in behavior in both directions, having that now involved in another type of function like this one, the idea is still the same as our kind of easy way approach to look at this. Since we're computing the limit at infinity, we can look at, I wouldn't necessarily call this a leading term, 7e to the x in the top, but it's definitely the dominating term, right? So this, we could look at this as 7e to the x over 3e to the x. And what's the limit as x goes to infinity then? Not 1, but
7/3.
7/3, right, because the e to the x's divide out. It doesn't matter how big those numbers are, they're always the same number. So this is just 7/3. So that function, whatever it looks like, has a horizontal asymptote at y equals to 7/3. And notice it's almost equivalent to, degree of the numerator, degree of the denominator, but not quite, because exponentials don't really have degrees. All right, we'll do it the long way just to show you the next time, but hopefully the board's more cooperative. I'm trying to mess with it, so I'll see you all Thursday.